Now in this video, we'll take a look at a slightly faster approach to check whether a number is prime or not. Okay, in the previous example, in the previous program, in the previous video, we had seen that if we want to check whether the number 1093 is prime or not, then the loop will run 1091 number of times. Okay, so basically what we do here is we straight away check whether the number is less than equal to 1, then is it equal to 2, and whether it's a multiple of 2. So is n mod 2 equal to 0? In that case we return false. Now we'll not continue this, we'll not do this for n mod 3 etc. We'll only check for n mod 2 over here, and then we'll only check for odd numbers. So we'll start with 3 and we'll increment by 2. Now this part is the most interesting part of this approach. Okay, now the thing is, if there is one divisor of a number which is greater than the square root, then there will always be one divisor of the number which is less than the square root. So even if you go up to the square root of n, okay, still you will find one divisor if it is not prime. If you cannot find a divisor which is less than the square root, that is up to this range, then the number has to be prime. Okay, because if it is not prime, then there will be one divisor which is less than the square root and corresponding other divisor which is greater than the square root. So we need not go beyond the square root ka range. So effectively for, let's say, 1093, if we want to check, then our range gets reduced to the square root of 1093, which is roughly, you can say, 32. Okay, close to 32. So this is a drastic reduction, right? Instead of running for 1091 times, now the loop will run only around 32 times. Okay, and even among that 32, we are incrementing it by 2 every time. So that optimization is achieved by this. Okay, because of this condition, so we have eliminated all the factors of 2. So if it is not divisible by 2, it is not divisible by 4, 6, 8, etc. Okay, so other part of this program is exactly the same. Okay, so my only focus here was to show you a faster approach to check whether a number is prime or not. Okay, thanks for watching.